Hello everybody and welcome to our short lecture series dealing with the basics or fundamentals of the immune system. In the lecture today we are going to be covering the so-called innate immune system, and in the second session next week we are going to be having a closer look at the so-called adaptive immune system. Before talking about the details of the immune system, let us briefly think about why immunology is actually relevant for future pharmacists and physicians associates. This is actually quite a big story. There are even few dedicated books for pharmacists and physicians associates, and also quite a lot of ongoing CPD sessions. So there must be a very good reason why you are learning this. The first important point is that both pharmacists and physicians associates are healthcare providers and must understand how the human body defends itself. You must understand consequences of either suppressing or enhancing the immune function. You need to also understand basics of hypersensitivity reactions to natural allergens and also pharmaceutical agents. In addition to that, many drugs act on the immune system. Examples of such drugs are non-steroidal anti-inflammatory drugs like aspirin, antihistamines, salicylates, but there are also dedicated drugs that are immunomodulatory. They are drugs that can activate or suppress the immune system. Most importantly, pharmacists might provide vaccines. Therefore, they must understand how immunization works and should be vaccine advocates. And this is a part of evidence-based approach. This is the case for the yearly flu vaccine, but most importantly, nowadays also if it comes to vaccination against COVID-19. In addition to vaccination, large number of immunologicals, drugs affecting or utilizing the immune system have entered the clinical area quite recently. And what you can see here are examples of such drugs in form of antibody-based drugs. Indeed, 8 of the 20 best-selling biotechnology drugs in the USA are therapeutic monoclonal antibodies. And if you are interested in monoclonal antibodies and the use of those antibodies as drugs, I recommend that you follow this link and have a brief look at this nice Wikipedia page where all of the drugs currently under investigation are listed. And as you can see here, you can use antibody-derived drugs for quite huge diversity of disorders and conditions, including cancer, but also autoimmune disorders. For the pharmacists within the cohort, there will be a lecture in part 3. And the 2 sessions delivered this and next week are essential for your understanding of the lecture, which is going to be delivered by Dr. Edwards in part 3. In addition, both sessions are closely linked to the content from the microbiology lecture series, which is going to be delivered by Dr. Black very soon, especially if it comes to vaccines. So, what are the learning outcomes for today's session? First of all, after watching all of the videos, after revising the content, you should be able to define innate immunity and discuss why this type of immunity is more general than the adaptive immune system. You should also be able, using examples, to explain why innate immunity is the immune system's first and second line of defense. Moreover, you should be able to describe physical barriers in the innate immune system and give examples for humoral components of the innate immune system. You need to be able to list the cellular components of the innate immunity and describe the functions of those cells and explain how infection leads to inflammation. Lastly, students must be able to list the 5 hallmarks of inflammation, since this is tightly linked to the innate immune system. So, what is immunology? How can we define this? Immunology is a branch of biomedical science that covers the study of all aspects of the immune system in all organisms, not just in humans. It deals with the physiological functioning of the immune system in states of both health and disease. And the term immunology is derived from the Latin term immunus, which translates to free or untouched. Per definition, the immune system includes all cells, tissues, but also molecules that mediate resistance to infections caused by different microorganisms, including bacteria, viruses, but also fungal disorders. Immunity is in this context the ability of the body to fight off harmful microorganisms or pathogens that invade it. For example, again, fungi, protozoans, bacteria, and viruses. The immune response itself is the collective and coordinated response to the introduction of foreign substances in an individual mediated by cells and molecules that belong to the immune system. So, what are the roles of the immune system in the human body? The first and most obvious function is defense against invading microbes. In addition, immune system is also in charge of defending the body against growth of tumor cells, and this is something we will understand in more detail after watching the videos within the second session next week. In this part, we will learn how the immune system is able to recognize and kill tumor cells. In addition, the immune system plays also an important role in tissue homeostasis. In this function, immune system is in charge of destruction of abnormal but also dead cells, for example, dead red or white blood cells within our circulation. So what are the components of the immune system in terms of organs? As you can see here, many different organs actually contribute to development of the immune system, including tonsils and adenoids. The thymus is a very important organ in the immune system, but also lymph nodes, spleen, the appendix, lymphatic vessel, and bone marrow. In addition to this, the bowel actually plays an important role, more specifically the microorganisms that are present in the bowels. They actually modulate the immune system. So what cellular components of the immune system we need to know? First of all, and most importantly, the cells of the immune system include lymphocytes that are T lymphocytes, B lymphocytes, and also plasma cells, natural killer lymphocytes, and monocytes and macrophages. And we are going to be looking at those cell types in more detail during both sessions this week and next week as well. Then we have also granulocytes that can be further divided into neutrophils, eosinophils, and basophils. In addition to cellular components of the immune systems, there are also molecules contributing to the immunity, including lysozyme, antibodies, and the complement system. In addition to those three molecules, cytokines play a very important role in the immune system, and I hope that some of you remember what cytokines actually are. Cytokines are messenger molecules activating certain signal transduction pathways in the cells. In addition to cytokines, interleukins play an important role in the immune system, and also interferons. With this, I would like to close the brief introductory session, and I will see you in video number 2. Thank you very much for your attention.